Okay, today we are on 6.5, operations with rational expressions. There's a couple of things I wrote down on the side here. Let's see here. I wrote to remember before we even get started. And yeah, this is 6.5 if that got cut off for you. Remember your even, even, odd. So this is your even, x to the even or whatever, right? And then x to the odd. So that would get absolute values. That's from before. Hopefully you remember that. So operations with rational expressions. So rational typically means that there's some sort of a root in it. So a square root, a cubed root, or whatever root. So this is going to be a little bit hard to understand at first, but once we do some examples, I think you're going to be okay. This is kind of a lot, so we usually split this into like 1.5 days. So we'll do like half of it today and then the other half tomorrow. So you're going to get confused on some, and that's okay, but you just have to kind of pick up where you understand. Just write it down, go back to it later, whatever you have to do. So there's some you're going to get, and there's some that maybe you need a little bit more help with, and that's fine. But don't just like not do any of it. That's probably not a good idea. So for n is greater than 1 for positive n's, which in this class I don't think that would ever be a negative anyway, then you can do this. This is stuff you should already know. If you have the nth root of a times b, you can pull them apart into the nth root of a times the nth root of b. That's not new to you. With numbers, I suppose, if I had the square root, for example, of, I don't know, let me think of something that works out nicely. I wouldn't want to pull it apart. It doesn't matter. Like 12 times 3 like that, you could pull it apart separately if that was helpful. If not, then you don't have to worry about it. Same thing here. If you have the nth root of something as a fraction together, you can pull them apart and make them their own fraction and then simplify that way. So a radical expression is simplified when the index, or the root, n, is as small as it can go. There's no factors except for 1 that are nth powers. No fraction in the radicand, so that means you have to rationalize the denominator if it's like that. And no fraction in the radicand. We'll get there. And no radicand in denominator. So you'll see what I mean in a second. We'll come back to that. Rationalizing the denominator, that's old, 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 old. Clearing radicals from the denominator. So when we had this, you multiplied by root 2 over root 2. When we had this, you multiplied by 1 plus root 2 over 1 plus root 2. You rationalize the denominator. Conjugate, that's what this is, the conjugate. So if this is 1 minus root 2, then this is 1 plus square root of 2. So it's used to rationalize denominators. The product is always a rational number. For example, 5 plus the square root of 3 and 5 minus the square root of 3. Those are conjugates. Remember, we had complex conjugates. I don't think you need to know that today, but if I have 1 over 2 minus I multiply by 2 plus I. That's my complex conjugate. That is all old stuff. I haven't said anything new yet. Like radical expressions, where both the index and the radicand are identical. So, do you see how this is blah, 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 cubed root of 4xy, cubed root of 4xy, cubed root of 4xy? So that's the same as like x, x, x. Okay? So, oh, sorry, that's the answer. Whoopsie. So if you have 3 of the same thing and 4 more of the same thing, then you have 7 of the same thing. So this is 7 cubed root 4xy. So because these are both the cubed root of 4xy, your answer is the cubed root of 4xy. Okay? So let's start where I think it's a little bit easier. Let's go to the next page. So I'm going to start on number 30. I think that's going to be the easiest one. So I'm going to go out of order. Or did I start with number 1? No, just kidding. Go back. Let's go to number 1. I put this in the order that made sense last year. I think it'll be good. So just kidding. Go back to number 1. So it says the square root of 36a, b to the 4th, c. So you take the square root of the easy stuff, the perfect squares, right? So what's the square root of 36? That's going to be a 6, okay? Square root of a, well, this is a to the 1. And this is a 2, right? If it's smaller than this, you can't take it out. You can't do anything to it. So that a is going to stay underneath the square root sign. What's the square root of b to the 4? That's a perfect square. What does it come out as? B squared. And then the c, that's a c to the 1, which is too little. So then I usually kind of shove them back together because that looks weird. So we have 6b squared square root of ac. Oh, did I write that? Oh, it says c to the 5th on yours. Man. Okay, if that was the question, we did it right. Let's do the actual question you have. 36a b to the 4, c to the 5th. Man alive. So just kidding. You don't have to erase anything. Just watch it. So we still have this is a 6. This still stays under as an a. This still comes out as a b squared. None of that's new. That's the same as before. But this c to the 5, okay? That's bigger than the 2. That's not a perfect square, right? But I can break it down into a perfect square. So isn't that the same as c to the 4 times c to the 1? Because that's 5, right? When you multiply, you add. So the c to the 4 comes out as a c squared, and then the c stays underneath. So our final answer is 6b squared c squared square root of ac. Then we have to check for even, even, odd. When you check for even, even, odd, you check the original exponents, not what you like messed with. So this originally was a 1, okay, not even, don't care. This was even, even, not odd, don't care. This wasn't even, so I don't care. So that's my final answer. Sorry about that. I haven't seen this in a year, so there you go. Okay, 21. Square root of 18, a to the 6th, b to the 3rd, c to the 5th. So the first thing you're going to do is break down the square root of 18. So you have to say, okay, what's the highest perfect square that goes into the square root of 18 evenly? So we've got a 9 and a 2, right? I'm going to go ahead and break these down into perfect squares. So we've got 9 and 2. This is already a perfect square because it's even. 6 divided by 2 works out, right? So I'm just going to leave it. This is not. So that's going to be b squared and b, because isn't that b to the 3rd? This one's a perfect square, it'll come out. This one's not a perfect square, so what would you break it down into? C to the 4th, and then you have a c left over. So let's bring all the perfect squares out. Square root of 9 is 3, right? A to the 6 comes out as a to the 3. B to the 2nd is a perfect square. It's b to the 1. C to the 4 is a perfect square. That's c to the 2nd. If you've forgotten your rules, if it's a perfect square with exponents, right, you would take 6 divided by 2, which is 3. 2 divided by 2, which is 1. 4 divided by 2, which is 2. Okay? And then we still have the 2, the b, and the c. So let me check what we have. 3a cubed, b, c squared, square root 2bc. Good. So now we have to check for even, even, odd. It had to have been even here to get absolute values there. So is this even? Yes. Even? Yes. Odd? Yes. Absolute values. Even? No. Don't care. Even? No. Don't care. So I know I broke them down into even exponents, but they weren't really even in the beginning. So my final answer only has absolute values around the a cubed part. Take a second, write it down. If you need to pause, pause. Okay, we're going to jump to number 30 now. Again, this is Algebra 1. This is not Algebra 2 here. These are not like radicands. It's the same as like saying like terms. This is like an x, a y, and a z, right? They're not the same. So I cannot go ahead and combine them like I did in the beginning of my notes where I did it right here. It's not like that because they're not the same, okay? So what we have to do is go ahead and simplify those square roots, and then maybe they will be the same. I don't know, but I have to try. So square root of 90, what is the highest perfect square that goes into 90 evenly? You've got 9 and 10, right? So what is the square root of 9? It's 3. So that breaks down into 9 square root of 10. Okay, now let's do this one. What is the highest perfect square that goes into 20 evenly? So perfect squares, if you've forgotten, are 4, 9, 16, 25, 36, da da da. So we have a 4 and a 5. What is the square root of 4? 2. And then that literally says 4 times 2 times the square root of 5. So that's 8 square root of 5. All right. This last one is a little bit bigger, but it's Algebra 2 now, right? So we're going to have a little bit harder numbers. So you're going to start dividing by your perfect squares until you find one that works. So again, 4, 9, 16, 25, 36, 49, what did I say? 49 to 7, so 64, da-da-da. So take a minute and you try to find out what goes into 162 evenly. That's a perfect square. I want you punching buttons on your calculator. 162 divided by 4, not pretty. 162 divided by 9, not pretty. 162 divided by 16, not pretty. Keep going. So you should have gotten 81 and 2. What is the square root of 81? It's a 9, right? So now that it looks like this, I can see if any of these are like terms. Square root of 10, square root of 5, square root of 2. They're not. So that is my final answer. I can't add or subtract anything because they aren't like radicands, but I had to try. I had to simplify anyway. "31 is the exact same thing. So I'll get you started and then I'm going to make you try it. So again, we can't go ahead and combine these the way they are, so we have to simplify them and then maybe they'll combine at the end. I don't know. So square root of 12, what is the highest perfect square that goes into 12 evenly? You've got a 4 and a 3, right? That's really 9 times 2, because the square root of 4 is 2, times the square root of 3, which is 18 square root of 3. Why don't you try the next two pieces? So this one's going to be 5. You have a 16 and a 2. Square root of 16 is 4, right? So that's 20 root 2. Try the third one if you haven't already. You still have your minus sign. That's 36 and 2, so 6 root 2. So we have 18 square root of 3 plus 20 square root of 2 minus 6 square root of 2. These are like radicands. What's 20 minus 6? So 18 square root of 3 plus 14 square root of 2. And that's all you can do. These are as simplified as they can be. And then you cannot combine the square root of 3 and the square root of 2. So that is our final I'm done answer. The next one we're going to do is 37. This, again, not new. It's Algebra 1. I don't say that for you to feel stupid if you don't know what you're doing. I'm just saying this isn't new, so don't be intimidated by it, okay? Pretend this said, this is like 7x, right? And then 4 something else, okay? So what you're going to do is you're going to FOIL, obviously, first, outer, inner, last. I'm going to go ahead and take these two times each other. You multiply the normal numbers together, and you multiply the square roots together. So it's 7 times 4. It's going to be 28. And what's 2 times 6? 12. They were under the square root sign, so they stay under the square root sign. And we'll simplify it later. Don't worry about that now. So now let's do our outer. 7 times 3, that's a positive, so a positive, is 21. Square root of 2 times square root of 12 is like this, right? So square root 24. And we'll simplify it later. Inner, that's a negative, that's a positive. So negative, what's 3 times 4? 12. And then 3 times 6 is 18, and it was under the square root sign. You try the last. Ask yourself what sign it is. Ask yourself what are the numbers. Ask yourself what's under the square root. So this is going to be negative 9 square root 36. Okay? None of those are like radicands yet, but they all can be broken down into simpler terms. So we need to do that. So we're going to break down the square root of 12, square root of 24, just like the last one, right? I'll do the first piece for you. What is the highest perfect square that goes into 12 evenly? We have our 4 and a 3, right? So that's really 28 times 2 square root of 3, which ends up being 56 square root of 3. So this guy goes all the way down here, okay? I'll do one more, and then I'll make you do these two by yourself. So 21, what's the highest perfect square that goes into 24 evenly? 4 with what left over? 6, right? What is the square root of 4? 2. So now I can multiply these together. 21 times 2 is 42 with the square root of 6 left over. All right? You try just this piece right here. The sign follows it all the way down. So simplify the square root of 18. So we've got our 12 still, 9 and 2. The square root of 9 is 3. So 12 times 3 is going to be 36, square root of 2, and that negative sign follows you all the way down. All right, what is the square root of 36? 6, right? So what's 9 times 6 with a negative in front? 54. Okay? Are any of these like radicands? Square root of 3, square root of 6, square root of 2, and then no square root. Nope. That's your final done simplified answer. There's nothing else you can do. Okay? 39 is the exact same thing. So I am not going to have you do that one by yourself because this one actually has a shortcut to it. Okay? You could do what we did before and say that that's 144 times the square root of 100, which is times 10, and then go from there. But this, if you look, is a difference of squares backwards, right? Isn't it the exact same thing with a plus and a minus in between them? So let's go back like a while. If I had x squared minus 4 and I was factoring it, okay, I would say x minus 2, x plus 2. That's what we have, but like way different, right? The idea is the same. So we have this, and I want that. So if you go back and remember, I'm always going to show you shortcuts from now on. If you want to take your time and FOIL all that out, you be my guest, but I'm going to do the shortcut. So the shortcut is first thing squared minus last thing squared. So the first thing squared is going to be 12 squared, which is 144, square root of 10 squared, which is just 10, because square root of 10 squared is 10. If you want to really do it, it's square root of 100, which is 10, right? And then it's always last thing squared. If it's a difference of squares, it's going to be a minus sign. So what's 6 squared? 36. And then square root of 5 squared is square root of 25, which is 5, right? So this is going to be 1440 minus 36 times 5 is 180, and then you actually subtract it, which is 1260. Once you know the shortcut, this takes you, I don't know, maybe 10 seconds. But if not, you'd have to FOIL, and it's going to take you at least a minute. I know that doesn't seem like a big difference, but when you're doing a homework assignment with 20 questions, a minute's kind of a big deal. If you didn't understand the shortcut, you're going to let me know later, or you're just going to go ahead and FOIL it all out like we did on the last one. That's fine. It's just extra work if you don't know the shortcut. Okay? 41. Let me make sure we want to do this one. Yeah, let's go ahead and do that one. 41, not new at all. We cannot have roots in the denominator, so we have to multiply by the conjugate. If this is square root of 3 minus square root of 2, what do I multiply on the top and the bottom? Square root of 3 plus, pretend that's at a 2, square root of 2. And what you do to one, you have to do to the other, because this is really like multiplying by a 1, so I haven't really changed the problem, okay? This isn't new, nothing new. You're going to FOIL or distribute, either way. So this is 6 square root of 3 plus 6 square root of 2. You can't actually combine those, so you're just going to write it like that for right now, okay? The denominator, again, there is a shortcut. If you want to FOIL, you go right ahead. But this is a difference of squares. So you take the first thing squared, it's going to be a 3, always minus. The last thing squared, it's going to be a 2. Well, that's just a 1, isn't it? So my final answer is 6 root 3 plus 6 root 2. Nothing else I can do. If you know these shortcuts, it takes like 10 seconds. If not, you're going to have to FOIL that, and you're going to get square root of 9, and then it's going to be plus square root of 6, minus square root of 6, minus square root of 4. Well, it's 3, minus 2 is 1, and even I was still going a little bit faster than you probably would, right? So this is your final answer. If you're not understanding shortcuts, you really need to start doing that, okay? Exact same thing. Take 10 seconds and write down the conjugate. what is it we're going to multiply by? It's going to be square root of 3 minus 6, square root of 3 minus 6. You multiply by the same thing on the numerator and the denominator. I'm going to make you try the denominator without me. Use your shortcut. First thing squared minus last thing squared. So this squared is square root of 9, which is really 3, right? Always a minus sign. This squared is 36, which gives you negative 33. Okay? The numerator, there is no shortcut here, so we're just going to have to FOIL it out. I don't really have room over here, so I'm going to go to the bottom. So this is going to be 9 square root of 3, because it's really a 9 times the 1 there, okay? Minus, what's 9 times 6? 54. This is going to be a minus sign again. That's going to be 2 times square root of 9, if you want to go ahead and write it that way, okay? 2 negatives make it positive. That's 12 square root of 3. So I'm going to start combining like terms and simplifying things, right? So 9 root 3 and 12 root 3 is how many root 3's? It's 21, right? So 21 square root of 3. And then this ends up being 3, because square root of 9 is 3. So what's negative 54 and negative 6 make? Negative 60, right? So I'm going to go ahead and put that up here now. 21 root 3 minus 60. So what I need to do is see if I can simplify these. So I've got 21 root 3 minus 60 all over negative 33. Okay? If I can simplify, I need to. Let me rearrange these. This isn't wrong, but let me write it this way. Negative 60 plus 21 root 3 over negative 33. We have a pi again. This is not in the pi because square root of 3 isn't 3. So these all have a 3 in common. 3 is their GCF, but this does not. Square root of 3 isn't the same as 3. So I'm going to divide all of these by a 3. Unless, can I go higher? Let's see. Did I go higher? No, I don't think so. So this would be negative 20 plus 7 root 3 over negative 11. And that's fine. You can leave it that way. This would be, where was our first answer? This would be minus a half if you left it that way. You have to do your pizza, basically everything but the root. If they have a GCF, you need to pull it out and simplify. Again, if you're lost on just like the last step, that's pretty good. Just come and see me during WIN and I'll catch you up. Let's see, what do I have time for? Let's see. I think we got time. Okay, so we're on number 7 now, so we're back in the front. Sorry I'm jumping around, but I'm trying to go like from easiest to hardest. So I'm going to go ahead and multiply the way that it is. 2 times 3, 3 times 2, same thing, is 6, okay? This is not a perfect cube the way it's written, and this is not a perfect cube the way it's written. So I'm going to shove them together and see if that's helpful, okay? So what's 36 times 6? Use your calculator. Don't make me do the math for you. What is it? 216 is what you should get, okay? And then x to the first times x to the second is x to the third. And then y to the first times y to the second is y to the third, okay?